Hello, I am Seema and welcome to part 16 of the chapter Hydrocarbons. In part 15, I introduced alkenes to you. Let us now do the nomenclature of alkenes. I'll not be spending time explaining nomenclature and the rules of nomenclature because I am assuming that you have already done the previous chapter in which that was organic chemistry, some basic principles and techniques, in which organic nomenclature was done very thoroughly. So in case you have not done that well, I would encourage you to do those videos first and then come to this. Although this is kind of, in that chapter we had covered far more complex nomenclature. Anyway, I'll start with the first compound. When we say alkenes, alkenes have a general formula CnH2n. So according to that, the first member of alkenes should be CH2, according to the general formula. But then this is an extremely unstable compound because in this the octet of carbon would not be satisfied. Now, being very unstable, you could say it would exist as an intermediate sometimes, but not as a proper compound. The second thing that we say about alkenes is that alkenes are those compounds which have at least one carbon-carbon double bond or one double bond between two carbons. So in order to satisfy that requirement, you need at least two carbon atoms in an alkene. So the first stable alkene is actually ethene, which has two carbon atoms and which kind of fulfills all the definitions, the general formula, as well as the requirement that there should be a double bond between two carbon atoms is satisfied in ethene. So the first stable member is actually ethene, though technically we may say that CH2, that is methene, is also an alkene, but it's very unstable, almost non-existent as an individual. So since we are going to do the naming of alkenes, let us start with the first one. This is the first compound that we are supposed to name. It has three carbon atoms, which means, what is the word root here? Prop. Since it's an alkene, it'll be an ene, it's a propene. Now, on which carbon is the ene present? We will always try to give the lowest locant to the ene, that is the double bond. So 1, 2, 3. If I start from this side, the alkene, that is the double bond, is on the second carbon. But if I count from this side, the double bond is on the first carbon. So I will choose this direction and I'll call it propene. The compound is prop 1-ene, propene. Okay, look at this now. This also has four carbon atoms, so it is bute and it is an ene. The ene is here. I will count from this direction so that I get the lowest locant for the ene. So this would be bute 1-ene, right? Now look at this. This is also butene. The only difference is that the double bond here is on the second carbon. If you count from this direction also, it is on the second carbon, and from here also, if you count, it is on the second carbon. So we'll write this as bute 2-ene. It is bute 2-ene. This is also butene, but it has two enes. So it is a diene. Whenever you have a that is multiple double bonds or triple bonds, we do not write just BUT, we write BUTA. It is written, the A is added there whenever you have a tri, that is multiple double bonds. So this would be buta, and it is a diene. But what is the position of the dienes? What are the locants that you would be giving to the enes? If you count from this direction, the double bond is on the first carbon and the third carbon. And if I count from this direction also, the double bond is on the first and the third carbon. So either way, you're going to get the same locant. So it doesn't make a difference which side you count it from. So I'll write this as buta 1,3 diene. So it is buta 1,3 diene. Now this is propene and it has got a branch, a methyl group on the second carbon. So I'll count from this direction, 1, 2, 3. So this is propene, and prop 1-ene, but the methyl is on the second carbon. So you write the substituent first. 2-methyl prop 1, 2-methyl propene, prop 1 ene. Now the next one, take a look here. CH2, double bond CH, CH, CH3, and there's a branch here. So there's a branch on this carbon, and you have the ene on the first carbon. So if I count from this direction, the ene is on the first carbon, and if I, first and 3, 1 and 3 are the locants. But if I count from this direction, the methyl group is on the second carbon, and the ene is on the third carbon. If you have an alkyl group and an unsaturation, you have to give the lower locant to the unsaturation. So I'll count from this direction, and I'll be writing CH2, this is butene, but 1 ene, but the methyl group is on the third carbon. So I'll write this as 3-methyl but 1 ene, 3-methyl butene. Right? So these are the IUPAC nomenclatures. These are the basic things that you have to keep in mind when you're naming alkenes. There is this example, an in-text question that is there. If we solve this one and the next one too, that will really help us solidify the nomenclature. And after that, you can solve the problems of nomenclature of alkenes which are there in the exercises. After that, I think that should be enough practice for you to know how to name them, especially when you have already done nomenclature. So we are now going to write the IUPAC names of these compounds. The first one is CH3 whole twice, CH, there's a double bond here, CH2, CH, a double bond between these two, CH, C2H5 and CH3. You know, whenever they write such a problem, they're only trying to trick you. They're only trying to trick you because they expect that you, first of all, whenever there's a bracket, it means that these two methyl groups are attached to this carbon. So instead of putting this bracket and making it complex, let me just expand the structure, because that helps me to understand this better. There's a CH3 here and there's a CH3 here. Basically, it's a branch. After writing it this way, it becomes easier for me to look at it and name it and count it. Another trick that they've done here, something to confuse you, is to put a C2H5 here and a CH3 here. You see, whenever you're, according to the longest chain rule, when you're choosing the longest chain, you will start counting from one direction. And if you count 1, 2, 3, 4, 5, 6, 7, 8, 9. But if I count here 8, 9 and 10, because C2H5 is nothing but CH2 and CH3. So actually your chain will be this one, right? So, and that methyl is a branch. This methyl is only a branch. So now what is the total number of carbon atoms? Let us count in the longest chain. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's a decane. Alright, but decene, and there are two enes, so it is decaene, you know, just as we had the buta, and when you have multiple enes, it is written as buta. Similarly, this would be written as deca. Now for the locants, let us count from this direction. 1, 2, you have a locant on 2, this is third carbon, so the ene is on the third carbon. Third, 4, 5, 6, this is the sixth carbon, these two are enes. Seventh carbon, 8th carbon, 8th carbon has the methyl group, and 9 and 10. 2, 3, 6, 8. If I count from this direction, 1, 2, 3. The first locant that you have is 3. So according to the lowest sum of locants rule, if you will be counting from this direction as it is, you will be getting larger numbers, the larger locants, because the very first locant that you're getting is further off from the end. So these would be your locants. 2 and 8 are methyl groups. So we'll say 2, 8 dimethyl. Okay, 2, 8 dimethyl 3, 6. Sorry, not 3, 6. We'll first write deca. Methyl deca 3, 6 diene. That will be the name. 2, 8 dimethyl deca 3, 6 diene. 2, 8 dimethyl 3, 6 decadiene or deca 3, 6 diene. Let's name this compound now. Now this has been given just by making the dashes to represent the bonds, assuming that you know the carbons and hydrogens. Every corner of the line is a carbon. And obviously all valencies that have not been shown by the carbon-carbon bonds, they have been sufficed or fulfilled by hydrogens. So if I had to write the expanded structure of this compound, I would write CH2 here, a double bond C, and a single bond C, a double bond C, single bond C, double bond C, single bond C, double bond C. So this is the number of carbon atoms that will be there. 1, 2, 3, 4, 5, 6, 7, 8. There are 8 carbons. And where are the double bonds? The double bonds are alternating. And now you fill up the hydrogens. 3 bonds already, so there will be 1 hydrogen. 3 bonds already, 1 hydrogen. 3 bonds already, 1 hydrogen. Right? 3 bonds already, so 1 hydrogen. CH, CH, CH. And this will be CH2. This is your compound. Now, if I have to name it, if I count from this direction, what are the locants that I'll get? 1, 3, 1, 3, 5, 7. And if I count from this direction also 1, 3, 5, 7. I get the same locants in both the directions just as I got it in butadiene, buta-1,3-diene. But this time how many enes do I have? 1, 2, 3, 4. So it's a tetraene. It's a tetraene, and how many total carbons do we have? 8 carbons. So it is octa-tetraene, right? So it is octa octa 1, 3, 5, 7 tetraene, right? It will be octa tetraene. 1, 3, 5, 7 tetraene. Let me now write the other 2 compounds and we'll do the nomenclature of those 2. Give me a moment. Now this is the third compound that we have to name. Whenever, I told you, whenever there's a bracket, try to open the bracket. And when you open the bracket and you write down the structure, it becomes easier. So you have the CH2, CH2, CH3 whole twice. So I'll just remove this. Put a bond here and remove this. And write the same thing on here. So you have CH2, CH2, CH3. So this is your compound. Now look, if you take this as the main chain, 1, 2, 3, 4, 5. If you take this as the main chain, 1, 2, 3, 4, 5, 6, 7. According to the longest chain rule, you will get a feeling that it would be right to have this as the main chain. But there's a problem in this main chain. The problem is that the ene, that is the double bond which is known as the functional group, that is not present in this chain. although it is the longest chain, the functional group, which is this double bond, is not in the chain, it is acting as a branch. But a functional group is so important that you cannot throw it off as a branch. It has to be in the main chain. In other words, whether this group or this group, which is a normal propyl group, a normal N-propyl group, if the propyl group was attached to the second carbon, we would have called it an isopropyl group. But this is a normal, since the first carbon is attached to it, it is a normal propene group. And now, which means that our chain is only this. And according to the lowest locants rule, I should count from this direction to get the ene, to give the ene the locant 1, and this group gets the locant 2. So this is 2 N-propyl but 1 ene. No, pent 1, 2, 3, 4, 5. Sorry, it's not but, it is pent. There are 5 carbons in the main chain. So propyl pent 1 ene will be your compound. Yeah. 2N, there should be a hyphen here also. Propyl pent 1 ene. Now come to the last part. This is again, it's been given branches and stuff just to get you off guard, to kind of, make you feel that it's very tough. But your job remains the same. You have to, whether you go straight like this or go down like a serpent, you have to choose the longest chain, which has the enes and the functional groups in it. So when I look at that, all I have to do is, I look at this, just look at this as a chain. What do you see? I am understanding that this should be the longest chain, right? Do you also feel that? If I go down like this, because this is just CH3 and this is CH2, CH3, but here I have a longer branch, so I couldn't have gone up here. This is longer. So my chain would be this one. It couldn't be the straight one because this is too long. This has to be a branch and this has to be the main chain. If they would just have written this whole thing here and the CH3 up here, it would have appeared simpler. Honestly, let me just write it down and show it to you. There's a CH3, CH2, 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 CH. This has a CH3. Then there's a CH here. There's a double bond C, C2H5 here, CH2, CH, CH3 here, and a CH3 here. So this is your actual compound. So do you see this? Once you write it down in a way that makes it simpler, so you have 2 methyl groups and 1 ethyl group. There are 3 branches, 2 of them are methyl groups, 1 is an ethyl group, and there is 1 ene here. So if I count, even looking at this, I feel if I had counted from this direction, my locants would be further away from the corner. If I count from this direction, all my locants are falling in this half. So 1, 2. A locant for methyl groups is 2, 2, 3, 4, 5, 6. 2, 6 is methyl. Okay. Then 1, 2, 3, 4. 4 is ethyl. Methyl. And the double bond is 1, 2, 3, 4. 4 is the ene. So these are the locants that you have. And what is the total number of carbon atoms? What is the parent then? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it is decene. So it is dec for ene. Since there is only 1 ene, you will not be writing deca as we did here also. Did you notice? There was only 1 ene, so I did not write penta. I just wrote pent 1 ene. Similarly, here this would be dec for ene. But from the alphabetical order, when you're writing down the substituents, according to alphabetical order, E comes before M. So you will write the ethyl first and the methyl later. So I'll write the name of this compound would be 4-ethyl. Alright, 4-ethyl 2,6 dimethyl. Dec for ene. Right? dimethyl, dec 4 ethyl, 2,6 dimethyl, dec 4 ene. So these are the names of the compounds. Now the next part of the question, that is the next question, problem 13.8 says that you have to calculate the number of sigma and pi bonds in all these structures. So this is question 13.8. 13.8 says that you have to write down the number of sigma and pi bonds. In order to write down the number of sigma and pi bonds are always equal to the number of multiple bonds. And the rest are all sigma bonds. Even between the two carbons which have a multiple bond, which have a pi bond, the sigma bond still exists. So let us start with the first one. How many pi bonds does this have? This has 2 double bonds. So it has 2 pi bonds. And how many sigma bonds? All the bonds between carbons and carbons are sigma bonds. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 sigma bonds are already there. Okay? 11 are between carbons. With every hydrogen there's a sigma bond. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. 22 are with hydrogens. So 11 plus 22 will make it 33 sigma bonds. Right? 33 sigma bonds and pi bonds are 2. Look at this one now. How many sigma bonds? All single bonds are sigma bonds. So let us first count the pi bonds. There are 4 double bonds, so there are 4 pi bonds. Come to sigma bonds now. Carbon-carbon bonds, 1, 2, 3, 4, 1 bond between these two, 2, 3, 4, 5, 6, 7. 7 sigma bonds between carbons. Okay, now how many hydrogens are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10. There are 10 hydrogens. 10 bonds with hydrogens. So 7 plus 10 is 17. So there should be sigma bonds should be 17 and pi bonds should be 4. 17. 1, 2, 3, 4, 5, 6, 7 and 10. 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes. So you have 17 sigma bonds. Right? Next is this compound. Look at this again. How many carbons are there? 1, 2, 3. So 1 sigma bond here between the carbons first we are counting. 1 bond here, 2 bonds here, 3, 4. 4 bonds. Then this is the 5th one, 6th, 7th. There are 7 bonds with carbons. With hydrogens, 2, 4, 6, 8, 10. 10 plus 6, 16. So 16 hydrogens. So 16 hydrogens means 16 sigma bonds. 16 plus 7 is 23. So there will be 23 sigma bonds. And how many pi bonds? Only 1 pi bond. So there are 23 sigma bonds and 1 pi bond. Come to this one now. Again count the number of carbon-carbon bonds. 1 bond is here. 2, 3, 4, 5, 6, 7, 8, 9. And here 10, 11, 12, because this is CH2, CH3, 12, 13. It appears to be having 13 carbon-carbon bonds. And hydrogens, count the hydrogens. 2, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 23, 24, 25, 26, 27. 27. 7, 8, 9, 10, 0, 40. There seem to be 40 sigma bonds. And how many pi bonds? I see only 1 double bond. So there's only 1 pi bond. 40. It says 41. Where have I gone wrong then? Maybe in the hydrogens, in the carbons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So 13, yes. So let us now count the hydrogens. For the hydrogens, let's go to this structure. How many hydrogens are there? 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. There are 28 hydrogens, so 28 sigma bonds with carbon hydrogen sigma bonds. So this will be 41. So there are 41 sigma bonds, right? So there will be 41 sigma bonds. So this was the nomenclature of alkenes. With this, I'll wind up this video. I would like to mention here that I am now putting the link of the playlist of the chapter on the video. So if you wish to watch the other videos of this chapter, just click the link and you can see all portions, that is all videos of the chapter. I'm trying to do this for all the other chapters that I've already done. So just click the link and go to the rest of the videos. If you found this video helpful, give it a thumbs up, subscribe to my channel, recommend it to your friends, and please keep returning for more videos in chemistry. Thank you for watching, and bye-bye for now.